Hi everyone, my name is Sophia Pedigo, and today we're going to be doing the third part of a video. I talked about the past couple of videos. Basically, we have a bar, and we're trying to create a temperature profile for this. So I'm going to start by importing NumPy, and we're also going to be making a plot of the temperature profile for this bar. So we're going to import from Plotly some subplots. Okay, so if you remember from my second video, basically I drew out a little bar and it was divided into different increments. And what we're going to be doing is we're basically using that same bar in this video, but we're just coding it out in Python. So it's the same physical situation, it's just that we're solving it using Python. So we're going to break up, like I had in my previous video. I had shown that I had broken it up into different little increments, and each one of them are numbered. So it's a 50-meter bar, and so we're going to say in x, x being the position, is equal to 50, so there are 50 little increments. And also, like I said in my previous video, we're looking at it's a temperature profile but varying the time. So we want to have different time increments. So we're going to say that there's 2,000 time increments. And also in the previous video, what we were doing is we had an equation derived based off of the heat diffusion. And I had denoted what was called R, and R was actually equal to the heat diffusion coefficient multiplied by time and divided by the position squared. So we've been given numbers for each of those quantities or variables. So we're going to say alpha is equal to 1. We've got delta x. Delta x is also equal to 1, and delta t is equal to 0.5. And that's an important thing to remember, that delta t is equal to 0.5. We'll be returning to that. So next, what we want to do is we have this situation set up. We've defined our variables. We have the situation set up with the bar. So what we want to do next is create an array with our variables. So we're going to have x sick. So these are this is our x increments here, and then we'll say that r is going to be equal, like I just said. Oops, I changed that. T. Sick. Okay, so next what we're going to do is we're going to look at creating the temperature array. So we've kind of got our position here, and we've got our R value, which is the delta T multiplied by alpha and delta X. But now let's make an array for our temperature values, and we're going to say that it's equal to, so it's going to be, the array is going to have in X elements, which is 50, and we're going to fill it with that value. And then what we're going to do, in the problem statement, we're told that the initial temperature is actually equal to 50 degrees Celsius, and the final temperature is equal to 80 degrees Celsius. So that should change our values. Yeah. So now you can see here what I did was using the indexing for the array, I was able to change the first value to 50 degrees instead of 20 and the final value to 80 degrees also instead of 20. So now that we've got that set up, I'm going to go ahead and just make our initial figure, and then we're going to kind of populate the figure with the temperature profile is kind of how I like to describe it, because we're just making a blank figure essentially, and then we're going to add all the temperature profile, I guess, once we add that equation. So right now I'm just making a plot with rows equal to 1 and columns equal to 2. So yeah. Cool. Nice. Okay, nice. So you can see that we've got starting at the initial temperature, it's 50, drops immediately down to 20, and then it goes back to 80. And that's just like, I called it our initial temp. I guess you could just call it the initial like temperature profile or whatever you want to call it. But next what we're going to do is we're going to essentially use a for loop. And the for loop is nice because what it's going to do is it's going to iterate through that equation we derived in the previous video. Oh, my battery's low. I gotta finish this video quickly. My battery's low. So it's going to iterate through that equation for each value of t in our array. So that's going to be, we're going to say in range 1 to our each temperature plus 1. And then we're going to throw in the equation that we derived, but it's going to be like an array format, I guess you'd say. Oops, not the curly brackets. And then we're going to add the R value, which we already calculated. I want to make sure I type this correctly. I did too. Cool. Oh, oops. All right, let's see if this works. Oh, nice. Okay, I'm really excited. So then this is our temperature profile um, for this pipe situation that we've got. And but one thing I want to show you, hopefully before my computer dies, um, is I very specifically used a value of delta t that's 0.5. But let's just see what happens when we change that, you know? It's kind of wonky. Kind of doesn't look the same as before. Let's mess around. Let's see what happens. Ow. I gotta shift enter everything. I forgot. Yeah, so still kind of funky. You can see at the top there's something kind of spooky going on there. Um, let's mess around. I'm having fun with this. Okay, so that seems pretty normal actually. Um, but as you can see, when we have a delta t value of zero point 0.5, this thing seems to work pretty well. It seems to give us a pretty nice temperature profile. Um, but as soon as you kind of start to play with that, if it goes over zero point 0.5, 1/2, things kind of start to get weird. So in my next video, what we're going to do is we're going to dive a little bit further into this, do some stability analysis, and then we're going to come back and using a slightly different method, we're going to look at this problem again and see if we still run into the same issue when we change our value of delta t. So that's in my next video.